Hi there, my name's Darren Campbell. I'm a developer advocate here at PubNub, and this is a tutorial for our Swift Chat SDK. So we've recently launched a number of these chat SDKs. The idea is that we want to provide application developers who are adding chat to an existing application or creating a chat application from scratch. We want to make their lives easy. And so we've created these SDKs that have high-level APIs and features such as typing indicators, message reactions, user metadata. So all of that can be easily added to an existing app. So if you're familiar with PubNub, you're probably already familiar with our high availability, our high reliability, and our low latency. And we've previously always provided these and continue to do so through what we call our core set of APIs. So we have core APIs for a number of languages, including Swift, and that allows you to exchange messages at the low level and add some metadata to those messages and persist them, which is great, works across any number of use cases. But if you start to want to create a chat application on top of those, there's a lot of repeat work that you'll have to do to build the typing indicator, to implement the message threading API, for example. So we've done a lot of that work for you. So if you look now, we have this whole new range of chat SDKs, including Swift Chat, and we have top level entities for chat, for channel, for users, for messages. And what I'm going to do in this tutorial is to just talk through at a very basic level how you could take advantage of these chat APIs and how you could create a basic chat app. And then I'll also go on to talk about how you might implement a production application, so some of the gotchas that you might want to be aware of as you progress your implementation. So I thought the best way to run this tutorial was to create a sample application that shows at a high level like how the APIs hang together, how to do some of the basic tasks like sending messages or reacting to messages. Much like any sample application that you find online though, please don't take this as the foundation to your next production level application. It's literally just there to show how the APIs work. It doesn't do much error handling and all of the normal caveats that come along with taking a sample app off the internet. What it does do though is it has the notion of public channels. So public channels in the chat SDK are akin to something like your Twitch chat or your like live events chat where anyone can join, anyone can react, but you're not going to have a deep conversation with people in these very high capacity chat channels. Then we also have supported by the sample app direct messages, which is a one-to-one message that you might have with your friends, for example. But what we don't have represented that the chat SDK does support is the notion of a group chat. So this is your WhatsApp group or your Telegram group where you can have maybe 4, 10, 20 friends in a group chat. I'm not sure how many people the chat SDK supports, but it's definitely more than 20 in a group. The application will allow you to send messages and also receive them, obviously. It will allow you to react to those messages. It will have read receipts. It will have the notion of users, both user names and user profiles. You will also be able to see a typing indicator, as well as a very basic login screen. Again, it's not the kind of login screen that you would have in production, but it's enough to get you in the application, to give your user a name, to see this user being created on the back end. So in order to get going with the application, first thing you need to do is to clone the code from GitHub. So I'm going to go ahead and do that now. And then just open that code up with Xcode. First thing to note is this tutorial is based at the time of writing on PubNub Chat 080 dev. The Swift Chat SDK is based on an underlying Kotlin multi-platform implementation. So there's a number of dependencies that the sample app will pull in. More information is available in the docs, but now we have the source code. The first thing we want to do is to populate the keys file. So you'll have your publish key here, your subscribe key here. The keys are obtained from the PubNub admin portal. So go to admin.pubnub.com. Again, more information available in the docs if you need it, but login, you can create a free login if need be. We don't require a credit card, so you'll be able to do all of this tutorial without providing us any kind of payment information. You'll be able to do this on the free plan. Create a new key set, which is going to be for this application. So Swift Chat Tutorial 1, for example, it's going to be a testing key set. We'll save that. And two very important things you need to enable. First one is app context. So any application that uses the chat SDK of any flavor. So Swift we're talking about now, but we also have Kotlin, we have TypeScript, we have Unity. Make sure that you enable app context. This is the serverless storage mechanism which the Chat SDK uses to store things like the user profile URL or the association between users and channels, and that's called the membership, and we'll come to that in future steps. So just save that. So that's required for any Chat SDK application, but this sample app will also use message persistence. So it's going to pull in the last several messages that have been written in any channel. So just make sure you enable persistence as well. The other configuration to be aware of is presence. So this sample app does not use presence. However, most production apps that are chat-based will have some way of showing if the user is on or offline. So you may well want to consider enabling presence in your application. So having done that, you now have a publish and subscribe key. So just copy those over to the keys.txt file. And then you can run the application. Let me make this bigger actually so you can see what's going on. And here we are at the login screen. Like I say, it's a very basic login screen that's not requiring anything of you other than just choose a name for yourself. And I don't have any imagination, so I'll just type Darren1. And then the first thing the application will do is to create at the back end some public channels for you. So the subsequent times you run this app, these channels will appear for you automatically, but the first time then they'll be here. The first time that it will need to create them, sorry. So there's no messages, obviously, in the general chat. It's the first time we've run this on the key set. Just as a slight aside, if you have BizOps Workspace enabled on your key set, you can see that these channels have been created under your key set. We've got general, we've got work chat. They're the only two channels that will be there at the moment. So we've got one user. Let's create another emulator and we can show a conversation happening between two users. Okay, I'm back. I had a bit of a problem with the emulators there, so I'm going to try re-recording this bit, but essentially we have two emulators now up and running, so I'm going to log in with Darren1 on the left-hand side and Darren2 on the right-hand side. We have a number of public channels that everyone is associated with, so we have a general chat here. We have the ability to send messages in the general chat. That message is received. We have the ability to react with different emoji, and obviously those reactions are reported in real time across all members of the channel. If we go into a direct message between Darren1 and Darren2, in fact, this is an example I was doing off camera. So you see I was sending a message. This message is currently unread by Darren2. When I open the chat, the message is marked as read, so you see an example there, and I can also start typing. You get a typing indicator, and I can show two typing indicators at once, and that will disappear after the default chat timeout. I think this is enough for a tutorial. So let me run through the code and just show how I built this and how the APIs hang together. Okay, so the first thing that the application has is the login screen. So the only thing this sample app is asking for is for a single string. I'm calling it the user ID here. Internally in PubNub, we have different concepts for the user's name and the user ID. The user ID is very important. In fact, you are required to provide a user ID when you're initializing PubNub. It's the first thing that you do. And this user ID needs to be unique for that user. So if the user logs into two different devices, you need them to be logging in with the same user ID, or at least you need to be initializing PubNub with their same user ID. It could be completely transparent to the user that all this is happening. Maybe the workflow is they are using a separate identity provider to log in, they're getting an external token, and then you're using that token or a hash of that token to provide to PubNub as the user ID. But all of that is a very long way of saying that there's going to be a login screen here. I'm capturing a username. This ends up at I think it's at the top level content view here. Yeah. So after I log in, the username is in this variable here, and I then convert the username. So to use the actual example, I gave the usernames of Darren1 and Darren2, didn't I? And so you can't have a space in the user ID that you provide to PubNub. So I just make sure that whatever username there is conforms to this pattern of it has to be between A to Z, lowercase, capitals, or it can be 0 to 9. But as long as the characters adhere to that pattern, then we're good with that. And then we launched this home screen page. So the home screen will have a bit of logic, but the most pertinent piece for our example here starts in the launch function. So if you are familiar with PubNub in general, so our existing core SDKs, you'll know the first thing you do when you use any of our SDKs is to initialize the PubNub object. And the same is true with the chat SDKs, it's just the naming is slightly different now. The first thing you do is to initialize the chat object. And just like with the PubNub object, we recommend strongly that you only have a single instance of this PubNub object that's shared across the life cycle of your application. And so you can provide the configuration with many of the same parameters that is provided to the PubNub object in case of the core SDKs. So publish key, subscribe key, there's that critical user ID that we created earlier on, and optional configuration parameters, like I suppose the example would be that typing indicator where it was timing out after 5 seconds of showing Darren 1 or Darren 2 was typing. You could have a different timeout. Maybe it's 10 seconds, maybe it's 3 seconds. There's a lot of other configuration you can provide. Retry timeouts, access tokens, I think, as well. Okay, let's talk a little bit more about after the chat has been initialized. So you see in my sample app here, I've got this post initialize function, and like you're not probably going to be doing this in your production application, but I just wanted everything to be self-contained and to just work with the client. You're probably going to have a server component, you're going to have pre-created channels with your key set. Just bear all that in mind as I start talking about what this very simple sample does. So the first thing it will do is to look at the user ID that you have logged in as. So you've obviously logged in with a name. I talked earlier about how that name is converted into a user ID. Well, this line here is going to upload a profile, a random profile URL that's going to give you the image associated with the user, as well as your username, which you provided in the actual login screen. So that updates the user. And then the next thing that is done is to create the channels. So the channels, if I go back to showing this in a example, so we have 2 public channels. We've got work chat and we've got general chat. And those now exist on the key set. Again, apologies for keep flicking back and forth, but I'm just trying to show how this is real. This data actually exists. So work and general, ignore this for now. I'll get to that shortly. So for example, in general, we have a profile URL associated with the with the public channel. This is of type public, and you'll also notice that this is a custom field that I provided for the profile URL here. So going back to the source code, you'll see that for each channel, so we'll talk about the public channel 1 first of all. This is the profile URL that I'm providing in a custom object, and I call this create public conversation. Now this is an API on the chat object created previously with the pub sub keys. So this is like a high level API to actually create the channel, the public channel, on the back end. It doesn't do anything more than create the channel, and obviously associate the name, the description, and the corresponding public object with that channel. So having created the general channel, I go on to create the work channel, and then I just list them in the UI. So both those channels are available. But the key to understand here is that the channels have been created through create public conversation. The third and remaining thing that the application does is to call chat.getUsers. So again, in your production application, you've probably got some logic where you have a dialogue where the user can select another user to talk to, or they can select a group of users, and then you hit start chat, and all those users are invited to the same group, or the single user is invited to a direct one-on-one conversation, and they join that conversation. All very well and good. That would have been more complicated than I really needed this application to be. So I took the shortcut of what I do. I just query the API to say, give me every user, give me the ID of every user. And then what I will do for those top recent 15 users that have been created, I will just populate the direct messages. So there's only one user in this case, but this is where this list is coming from. This chat.getUsers, and then all users is being populated with this list. And then when I click on this user, obviously this is launching the conversation with Darren 2 in this case. But at the source code level, now remember I said that the public groups were created on initialize, but the direct groups aren't created until I actually click on the user. And I mean, that's a little bit further on. If I just say create, that's here in this user selected callback, create direct conversation. So that's the companion application, if you will, to the create public conversation. We have a create direct conversation. And again, I've taken the shortcut. Like in your application, you might choose to only have the initiator create the conversation, whereas like rather than have to check who initiated it, who is joining, accept the invite, I'm just taking the shortcut of if two people try and create the same direct conversation with each other, then the chat SDK is going to return a handle to the same instance of that application. And then just to tie this all back together, so remember earlier on I showed in BizOps Workspace for the public channels, we had the two channels created when the app was initialized. When the create direct conversation API is called, then the channel is created at the back end. So this is a channel ID which is determined by the SDK. This isn't something that I've chosen with all these random characters here, but this is a conversation between two different members. So the members of this channel are Darren1 and Darren2. And earlier on, when I was talking about the invitation being sent by the person initializing the conversation and receiving the invite and accepting the invite and joining, all of those are different ways of those two users becoming members of this conversation. So all of that has been done automatically for you by just calling that create direct conversation API. Back in the homescreen.swift file, the only other thing worth mentioning in this file is channel selected. So I've got a user selected when you click on a user in the simulator down here. So this is going to invoke user selected. Selecting either one of these is going to select channel selected. All channel selected does is just to change the state of the application so that the active channel, channel being a feature of the SDK. So channel is a class that the SDK exposes, and part of the state of this application is which of those channels is active. In this case, we have no channels active. Now we have one channel active, which is the general chat. Although maybe not true of a desktop application, so on mobile you probably are only going to have one channel active at any one time, so this is probably representative of how you might architect your production app. Okay, let's talk through the chat screen Swift, because there's quite a lot going on here that's worth explaining, quite a few different concepts. The first one, probably easiest to understand, is we have the state of the chat, which is going to be a list of messages. So these are of type message impl. The Swift SDK is unique. If you look at some of the other chat SDKs, what they will refer to as message, the Swift Chat SDK will call message impl. Similar for users, we've got user impl, chat impl, etc. It's just how the API has been designed, how the SDK has been designed. And we have read receipts associated with the chat channel. So again, to take us back, this is what a message looks like. The message will have a number of reactions. The message will also have read receipts associated with it in the case of a direct conversation. But in the case of public channels, then there will be no read receipts associated with the message. It's just not something that a public channel supports. Again, remember I said a public channel is akin to something like Twitch chat. You're not going to be having read receipts in Twitch chat, for example. That's the way to think of these things. And so yeah, they're the state. And then the other thing that's worth mentioning is membership. So if I go down here, this is the code that's executed when the chat screen is launched or relaunched, whenever. And it will, first of all, populate the header. So it's not doing anything too complicated here, but it's just essentially getting the different members of the channel, and if it's a public channel, then it's just going to say the name of the public channel with the avatar, else it's going to say the other person that you're chatting with in the channel. So that's the header. And then the next thing it does is it gets the membership. Now, as I was creating this sample app for Swift, I tried to create and have the same logic as the Android Kotlin example, and I only literally just realized a few minutes ago that I implemented the message retrieval logic slightly differently. But it's interesting because it shows that there are more than one way to retrieve messages. So what I do in this Swift example is for public channels, in fact for any channel, I use the connect API. So you can call channel.connect, and what that looks like in the the SDK here is you have a connect API and you can provide a callback, and that callback will be invoked whenever a new message is received on that channel. So that's one way of receiving a callback. The other way is to actually be a member of that channel. So what you could do, rather than call connect, you could also call join. When the SDK creates a direct conversation, so create direct conversation, the actual, that's what the method's called, underneath it will create a association for all of the users who have been added to that channel. So they're called members. I covered that earlier on when I was talking about these are the members of the direct channel, and you see it created those 2 users. That was all done automatically. In the public channels, however, the API, remember, was create public conversation, and that does not automatically create the members, create these memberships. So you do not have in this sample, you do not have a membership to any of the public channels. Now, there's no reason why you couldn't be a member of the public channel, but there's no real reason to create that membership. So let me explain. You might want to be a member because when you're a member, you have access to the membership object and you have access to the APIs that membership object provides. In this sample, the key API we have is the ability to provide read receipts. And if I go back to here, in fact, I'll come onto it shortly, but the ability to stream read receipts and be notified when your message goes from sent to read. That's not possible on public channels. So you don't really need to be a member of public channels. So this is just one way of handling your logic. So we, in this example, connect to the channel, provide a callback, and when the message is received, this is a new message received on the channel, I append that to the messages state. Again, this messages state is defined up here or as an array of message impl. And then what I do, whenever I receive the message, I call on my membership object, and we have the question mark here. So if this is null, so this will be null for public channels, but for direct channels, it will be instantiated, and we can call set last read message. So this is where the conversation comes in of what does it mean to read a message? So like here, we have a message which is unread, and this was a message that was sent to Darren1, and I haven't read it because the chat window hasn't been launched. Now, when I load up that chat window, it's going to mark the message as read. But you could conceive that I might have some logic where it's only read if the chat has been loaded for a couple of seconds, or maybe the user, Darren2 in this case, has scrolled to the bottom and actually seen the message within their visible window. So that's up to you as the chat app developer when you call set last read message. And that's what that's going to do, is that's going to tell the chat SDK that the message that you're indicating, in this case this message here, has been read by the user. And we'll get on to how that display is updated subsequently. All of this logic applies to new messages. And then we have essentially a duplicate. And I'll come to an example that hopefully makes this a little bit more coherent shortly. When we load the channel for the first time, and you can see this has happened in the simulator at the moment, we've loaded the channel. There are 4 historical messages. So this channel.getHistory has been run, and it's calling a maximum of 20 historical messages. Just as a brief aside, I think by default, if you don't specify, it will load 25 historical messages. There is a paging system, so you can get more messages if you need to. See the documentation for more information. And when you get the history, it will get the message as well as any metadata associated with that message. So in this case, it's going to be the message reactions associated with the history. So then we update our messages array with the historical message that's been received, and we will always assume that a old message, a historical message, has been read. So that's why we're calling this set last message time token. And then finally, we stream updates on all of those read receipts just to make sure that our read receipts stay in sync across all of our users. So you can see this happening if I, so this is currently not read. this is a historical message. So now I will load this. It will load up the 4 historical messages, 1, 2, 3, 4. And notice how this line got executed here, set last message time token. And that went through a series of events that caused this this icon to be updated because it was streaming the read receipt on this message object because this API here had previously been called. So that was on old messages. Again, similarly for message reactions, you see I've added a reaction here. If I load back out of there, then it's going to load in historical messages, including the reaction which happened, as well as new reactions that happen. It just covers all of those bases for old messages and new messages and message reactions and read receipts. Let's just make sure I have covered everything in this file. So chat screen, I think the only thing left is the logic for message input. The message input is the message input field at the very bottom here. It also covers the typing indicator. So let's just run through that quickly. I'm handling message input as a separate component, which has an associated channel. So there's 2 methods, elements of state, which I pass in. The first one is send message. So this is a function which is invoked whenever the user, in fact, I can probably show it in the code, whenever the user submits the message. So it literally just sends the text that's in the text field to this send message function. And all send message does is there's a send text method on the active channel object. Remember, channel is a class within the chat SDK, so it exposes the send text method, just pass it some text. And like, I know I talked an awful lot about receiving messages. Well, that's the other end of the exchange, arguably an awful lot simpler. And then we've also got, as part of the message input, the typing indicator. So there's 2 elements of the typing indicator. So the way it works is whenever someone, or like whenever the user is typing, you tell the chat SDK that a particular user is typing, and you do that through the start typing API. You see the logic is on change. So whenever the message input changes, it invokes this start typing API, and then apologies for keep flicking back and forth. It calls start typing on the active channel. This will only work for non-public channels. So in this example, we're showing it for direct one-on-one conversations, but it will also work for group chats of any size. So this does get quite difficult to implement if you were doing it yourself at scale. We have multiple users typing at the same time. You'd probably have to maintain multiple timers of when those users stop typing. The state gets more complicated the more users you have. So the chat SDK takes all of that complexity away for you. Under the covers, it's using something called PubNub signals. So it's doing it in a very efficient and cost-effective manner as well. And then, so that's how you send. So I've got the typing indicator set up to just display the user ID. You can obviously get more complicated than that and more efficient. So under message input, I had start typing when the value changed, but then I also need to register to receive like updates when the list of typing users updates. And that's done through channel.getTyping. Pass it in a callback. You get an object returned, which is a mapping of, no, it's not a mapping, sorry, it's an array of the user IDs of who's typing. And then it's up to you as the developer to do something with that array of user IDs. So at the moment, all I'm doing is like concatenating them with a separator, and I'm just displaying that on the screen. That's the simplest possible thing you could do. In production, you're probably going to want to like do the lookup between the user ID and the user name, or maybe you display their actual avatar. Maybe you have a list of avatars of people who are typing. If you were going to do that, there's a method called chat.getUser, which will return a user object if you pass it in a user ID, so it's ideal here. The only downside to that in this sample app is that that does require a network call under the covers. So obviously the typing indicator, this is going to be doing an awful lot of lookups, so you'd probably want to cache those values, and I felt that if I start implementing a caching mechanism, that would have complicated this sample application. So I didn't go ahead and do that. But just bear that in mind if you were doing a production app. That's one of the first things that you would do. And actually, at the very end of this tutorial, I'll point you towards a separate demo which we have written in TypeScript actually that does do all of that caching. So if you're looking for an example of it already done, then we do have that available as well. And that pretty much covers the typing indicator as well as the message input. Next, I'll talk about the message list. So in the sample app here, we're displaying messages in a scrollable view. Just like to point out some attributes that each of these messages have. They have a sender. So we're only really displaying the sender for received messages, but obviously these messages have a sender as well that have been sent. The sender has a name and a profile URL associated. We're also even displaying a little presence indicator down there. That is hard-coded to always be online, but in your production app, there are hooks where you can get the actual presence of the user who has sent that message. So you would be able to display the actual online or offline status of that user. The message also has text associated with it. Obviously, it has a reaction. In fact, this particular sample has 2 reactions, although in production, I can guarantee you will have like a dynamic list of reactions. And so rather than displaying every single possible reaction that the user could apply or every emoji that the user could apply to a message, you'll probably just have this count down here. And if there is more than one of a particular type of emoji, you would display that emoji on the, I mean, it's up to you. The UI is entirely up to you, but I'm just saying what would be most sensible. And then finally, there is the read receipt, whether it's sent or received, it's displaying a single or a double tick. So let's just talk through the logic of how that is put together. So back up in the chat view itself, the messages are rendered within a scroll view. You have a for each, so this is going through each of the messages in this messages state. Messages, again, is an array of Chat SDK message objects. Those are uniquely identified by the message.timeToken parameter, and that will be useful later on again when I talk about how read receipts are determined as well. Spoiler alert. And then we display a message view. We just figure out a couple of attributes of that message. So whether or not it's sent or received, we can compare our user ID with the user ID of the sender of the message. And whether we are in a public channel, we obviously need to know that because we want to know whether to display the read indicators or not. Obviously, read indicators not available for public channels because that's just not the way the Chat SDK is designed. Finally, read receipts. These are determined at this level in this sample app because whenever the receipts are update, remember I streamed for updates on the read receipts earlier, I'm just passing all of those, or the latest value as the state of read receipts into each message as it's being rendered, and then it's up to the message itself to determine whether or not it's been read. And then finally, obviously we need to pass in the text of the message itself. So let's have a look what that looks like. So I had message view. I'll just pick out some of the more interesting attributes here. Probably, let's talk about read receipts first of all, because that can be the most difficult thing to get your head around. So read receipts here is declared as an array of mappings between time tokens and arrays of strings. There's a lot of words there. What does that mean? So think the easiest way I find to visualize this is think about a group chat. I know we're only talking about direct messages in the sample application, but read receipts will also work for group chats. So it needs to be capable of capturing all of that information. So let's say I send a message to a group chat, a private group chat, which has 4 people in, and 2 people read that message. So how is that captured within the read receipts object? So the way it works is the message has a unique time token, which I said a little while ago, and that is used as a unique way to identify that message, and then that will map to the array of user IDs who have read the message. So anyone who is not in that array is assumed to have not read the message. and the time tokens will obviously increase as time goes on. So you would end up in a state where you have older messages that have been read by some people, and the latest messages, the ones with the most recent time tokens, have been read by, like, again, a subset of people. So you can use that array to figure out, hey, well, this is my message ID. This is where I am in that read receipts array, and then I know who's read me. I can assume that everyone who has read me has also read earlier messages. That's one of the fundamental assumptions here. And so I can then present that information to the users however I choose to. Now, I've explained that in that quite complicated concept just to give you the idea that you have full control as you are developing your UX for your read receipts, how you display that. So you imagine in WhatsApp or Telegram, it says like read by, and then it will give you the names of who have read your message. I am obviously not doing that in the sample app. I just literally have a one tick or a two tick that if anyone has read this message or a more recent message, then display two ticks, assume it's read, else assume it's unread. And the logic for that is down here. So obviously we only process this for messages that we have sent, and we have this process read receipts method, and this is contained down here. So process read receipts takes in that read receipts that's passed in from the higher level, and it will just work out, like for each of those read receipts, I'm doing some debug because I was struggling to visualize this myself as I was sort of typing it out, but it just helps me. I didn't have anyone to, I didn't have a tutorial to watch when I was doing it. That's the other benefit, of course. So yeah, message.timeToken, the key for ourselves, compare that to the message time token in the read receipts array, and then just figure out, has anyone read it? If the number of people who've read it is greater than 1, then that is true. Now, obviously, just like I was saying with the typing indicators, we're talking about user IDs here. So if you were having that experience of read by, you'd probably want to convert that user ID into a username using one of our methods like chat.getUser, or there are other ways to like stream updates to usernames that you can register for callbacks on. Not in this sample. Again, that is in the sample that I'll talk about at the end of the tutorial. And then what else do we have? That's the most complicated thing we're doing in this class, to be honest with you. We are, for each message, so if it's received, display the avatar of the sender. Again, like we are hard coding in this sample the presence indicator, but there are ways to get the presence and stream that, so that will update in real time. And we display a message reaction view. I'll talk about that shortly rather than go into that in this class. And the only other thing is the message text. So message text is obtained through the message.text, quite easy to access. It's just a text string, and the rest of it is involved in just display. And then on to message reactions. So message reaction view here is quite a small class. You can fit it all within one screen. Well, I guess you could say that of any class, depending on how small you have the font size. So what we're doing here is encapsulating each one of these individual emoji components that's associated with a message object here. Obviously, in production, I think I've said this previously, but you would not typically have every single emoji that a user could apply to a message. I've just done this for simplicity and to make the sample app easy to use and understand. You would probably have some way of allowing the user to choose a message, but after they've chosen that message, you then need to tell the chat SDK the user wants to apply this string, this emoji, to this particular message. And the way they do that in the chat SDK is there is a toggle reaction API, which is exposed by the message object, and you pass it in. I mean, I'm calling it emoji here, but you're just passing it in a string. And what that will do is that will toggle the emoji. So at the moment, this particular message object has one reaction applied for smiley face. And when I click it, that unticks it. When I tick it again, it reticks it. You can get that number up to 2 if someone else applies with that same emoji. And then to bring this all together, you need to have some way of actually determining the number of emojis that have been reacted of a particular type for a particular message. So the way that that information is presented to you, the developer, is in the chat SDK here, like the sample app. This is how I get the count of each emoji. So if we access this message actions reactions property, we get a mapping between emoji and the list of users who have reacted with that emoji. So those users are a user ID. And the key is the emoji itself. Remember, emojis are just strings. So you end up with a list of keys. Let me just take this back to this concrete example. So here we would have two keys. One key would be the string representing this emoji. One key would be the string representing this emoji. And that would map to an array of single values. So this single value would be the user ID of whoever has reacted to this message. Now, I'm not like, you can imagine a scenario where you hover over it and it says liked by this user or that user with their username. I'm not doing that. I'm just actually literally counting them and displaying that count within the count field. And with that, I think we've covered all of the functionality of the sample application that I put together for the Swift Chat SDK. So thank you for listening. Hope you found this useful. The Swift Chat SDK is obviously a lot more functional than I've shown here. I would highly recommend checking out our documentation. So you can go to pubnub.com/docs and choose the Swift Chat SDK. Just make sure you've got the Chat SDK and not the Swift Core SDK from like Home, General, Chat SDKs, Swift Chat. And the best way I find to get started is, I mean, there's these get started sections here, but if you just want to understand the capabilities of the SDK, then these chat entities up here I find are really useful. So you can actually go through, this is the chat object, it will go through, like I discussed creating a direct conversation and a public conversation, but I didn't cover group conversations, didn't cover deleting channels, I didn't cover like getting users, streaming user updates, whether they're present or not, marking all messages as read, push channels, that's a fundamental feature of any mobile application, be it Kotlin or Swift. And all of this information is accompanied by code samples, so strongly recommend our documentation. If you want to see some of these more advanced features in a demo, like for example, just choosing this one, like stream updates on a user, then we have on our demos page, we have the chat demo. This is written in TypeScript, React, so it's not using Swift Chat SDK, it's using our React Chat SDK, but it does at least show these features like pinning a message, quoting a message, having a user profile, having an actual private group where you can select users from the list of people who have previously logged in. It should feel familiar to you. It has this same login screen. It's just a lot more functional and obviously renders online. But other than that, if you have additional questions, feel free to reach out to me. I've been Darren Campbell of the Developer Relations team. You can email devrel@pubnub.com. We're always available on our support. But other than that, I hope you found this tutorial helpful, and best of luck with your development.